Hello students, today we'll be discussing about general principles and processes of isolation of elements. Here we'll be discussing about what is metallurgy. Now, you know that metals, most of them are got from the nature. Some of them are reactive in nature, and those reactive metals are always found in the combined form. And the combined form of metals are known as minerals. So, how do you define minerals? They are naturally occurring compounds of metals. On the other hand, you find that some metals remain inert in nature or they are unreactive. Such metals we call it as noble metals: gold, silver, platinum. These are found sometimes in nature in the pure form, that is 100%, and they will be called as nuggets. You find that the largest ever isolated nugget of gold is known as Welcome Stranger, and it was isolated from Australia. You find that it is around 71 kilograms. We shall discuss about the terms used in metallurgy. First one, ores. Ores are minerals from which the metal can be extracted profitably. Next one is gangue. Gangue is the impurity present in the ore. Metallurgy means it is the science of extracting metal from its ore. It follows different steps. What are the different metallurgical operations that we'll see now? There are 4 steps involved in metallurgical operations. First one, concentration of the ore. In this method, we are crushing the ore particles into fine powder and removing the gangue particle present in it. Second one, after you get the concentrated ore, we have to convert all the ore particles into its oxide, because in the next step we are removing the oxygen from it, causing reduction, so that the metal is got in very easy steps. And finally, whatever impurities are present in the step is removed by purification process, which is known as refining. So the main metallurgical operations are concentration of the ore, conversion of the ore into its oxide, reduction of the ore, and finally refining of the metal. We'll see the different concentration methods. First one, hydraulic washing, otherwise known as gravity separation. In this method, the ore particles which are heavier are separated from the lighter gangue particles by using flowing water. That is why it is called hydraulic washing. You find that the difference in the gravities help in separating the components here. That is why it is understood as gravity separation. Here, the powdered ore is spread on a sloping table which contains many reefs, and water is allowed to flow from one side when the lighter gangue particles get separated from the heavier ore particles. The next method of separation is known as magnetic separation. Here, we use this method when we have the crushed ore which contains a non-magnetic ore particle and a magnetic gangue particle, or vice versa. Here, the powdered ore is spread on a conveyor belt which is rolling with the help of a magnet. So one of the rollers are made into a magnet, and once it starts moving, the powdered ore also will be carried away along with the conveyor belt, and as soon as it reaches the verge, you find that the non-magnetic particles fly away tangentially, whereas the magnetic materials get attracted towards the magnet and get separated. Hope it is clear. Coming to the next method, which is a very important method in concentration. This is known as froth flotation process. This process is mainly applied when we have to concentrate sulfide ores. Here, the powdered sulfide ore is mixed with water to form a suspension, and the suspension of ore particles with water is mixed with pine oil. Pine oil becomes the collector here. You find that oil and water never mixes. Once it is agitated with the help of a paddle wheel, it forms a lot of froth. So when froth is formed, you find that the ore particles get stuck on the surface of the pine particles. This occurs because there is preferential adsorption of ore particles over the oil particles, whereas gangue is wetted by water. So you find that all the ore particles can be skimmed out. You know that the bubbles formed or the froth formed is transient in nature. That means it breaks very fast. So in order to increase the stability of the froth, we are using a few drops of cresol or aniline into it. And suppose you are given a mixture of zinc sulfide and lead sulfide. We are adding a chemical which is named as depressant. This depressant preferentially helps in suppressing the zinc sulfide into the solution from coming up by adsorption on the bubble. Hope it is clear. Once the froth is formed, it is skimmed out and dried to get the concentrated sulfide ore. The last method of concentration is known as leaching. Chemically, leaching means chemical washing. In order to concentrate a particular type of ore, if you are choosing a suitable reagent in which only the ore particles get dissolved and not the gangue, that process is known as leaching. Leaching can be done for noble metals as well as aluminium. If it is leaching for noble metals, the process is known as cyanide process. Here, the noble metal is treated with cyanide solution in the presence of air to form a complex along with alkali. This complex formed is further treated with a more reactive metal, zinc, to form the complex of zinc displacing the noble metal. Likewise, we are able to separate out only the pure metal from the compound. Now, coming to the last method, that is leaching done for aluminium. The leaching of alumina is done by Bayer's process. Here, the alumina, which contains impurities like silica and titanium dioxide, is treated with sodium hydroxide solution to form sodium aluminate. This sodium aluminate is basic in nature, so it is treated with an acidic oxide like carbon dioxide to form a hydrated alumina. This hydrated alumina on further heating undergoes dehydration to form pure alumina. So what is the difference between Al2O3 given here and the initial one? Initial one